Hi, everyone. Let's talk about climate and architecture. Here in our natural world, there are many different climates. In extreme climates, very hot, very cold, you as an architect would design for the predominant need, whether it's hot or cold. However, in temperate climates, which is much of the world is temperate, buildings have to be designed for both heating and cooling. Why do we care? Why are we talking about this way in the beginning of our semester? It's because the climate in which your building is located sets the architect's design priorities. A building designed for the climate in which it's located will be more energy efficient. And so it's very, very important to actually know the climate that you're in and to know whether heating loads or cooling loads dominate. And here from your textbook is a graph of some examples. So we've got a couple of extreme climates here in Russia and here in Indonesia. Um, where it's very obvious that you should be designing for a cold climate or a hot climate. But in much of the world, and in fact here in the US, it can vary. And so we need to study specifically the location that you're in to know um, if you need to be more worried about heating your building or cooling your building, or in fact, both. Different building shapes or forms are more appropriate for the different climates. So let's take a look at this illustration from your textbook, starting way here in the very left. In the coldest climates, you want to have the most compact shape possible. All right, minimize your exterior square footage, your exterior area. A little bit less cold, okay, but still cold. Again, we are minimizing those exterior exposures. Your standard or your temperate climates will move into a little bit more expanded shape. And then there's a difference between hot and dry climates and hot and humid climates. Your hot and dry climates will often include a central courtyard, a protected and shaded space, right? But they're not trying to trap the the ventilation, trying to trap the wind as much as your hot and humid climates right here, which will include a central or protected cool and shaded place, but the exterior porches will trap any winds that are coming by. Many of the ideal building forms that we just saw can be seen in vernacular architecture. Now, you might not know this word, but vernacular is a design based on local needs, local materials. It reflects local traditions, and at least in pre-industrial societies, it was built without architects. All right, so no professionals involved. And therefore, it involves a very wide range of buildings, building types, building traditions, and different kinds of construction. Let's take a look at a couple of examples of vernacular architecture and the different building forms. So starting with a hot and dry climate, we see this example of massive construction, small windows, light colors. In a hot and humid climate, remember we want to catch those breezes, so natural ventilation, shaded windows. Moving to the very hot and humid, here we have a building raised up on stilts, high roofs, open gables, and absolutely maximum natural ventilation. They really, really want to catch the wind. Here's a similar climactic need, a very hot and humid climate, but a different vernacular because it's in a different place. And so we see wind scoops on this building in Dubai. And we've got some lightweight construction to address the humid climate. Moving to a temperate climate. In a temperate climate, you need to address both heating and cooling. And here we've got a standard or a compact building shape, but it's using bay windows to capture the light. And finishing up our discussion, in cold climates, we want the building to be compact, thick walls, and few openings. Keep the heat inside. All right, this semester we're going to be talking more about climate and how it affects buildings. You've seen some overall general effects on building form. And just keep in mind, it's very important to know the local climate that you're in because this will set your design priorities.